Alright, testing. Okay. Chapter 2, Radar Subsystems. Non-resident training course, Navy Electricity, Electronic Training Series, Module 18, Radar Principles. Alright, Chapter 2, Radar Subsystems. Due to the completion of this chapter, the student will be able to describe the general terms function of the radar, synchronize with the shape of the basic requirement of the type of the master, synchronize with the describe the purpose requirements of operation of the radar, modulator, describe the basic operation, sync with the key oscillator transmitter, describe basic operation sequence of power amplifier transmitter, state the purpose of the duplexer, state of the operation principle of the TR, ATR attributes, discover the basic operating sequence of the series parallel, connect with the duplexer, list of the basic design requirements of the effect of the radar receiver, list of the basic major sections of the typical radar receiver, using block diagram operational character for the typical radar receiver. Introduction of radar systems, subsystems. A radar system has several major subsystems that perform standard function. The typical radar system, called the synchronizer, also called the timer, the trigger, generator, the transmitter, the duplexer, receiver, the indicator. The major subsystems were briefly discussed in Chapter 1. Chapter 1 will, the chapter will describe the operation, synchronizer, transmitter, duplexer, receiver, the typical pole for the radar system, briefly analyze the circuit. Even in Chapter 3 will describe typical indicator, the antenna subsystem, the cover of the radar system, vary widely, specifically designed. Only general descriptive and representative circuits are presented in this chapter. A synchronizer is often referred to as the heart of the radar system, to cover the control of the provided timing of the operation for the entire system. Other name of the synchronizer are the timer and the key, or that you believe the term is synchronized in other discussions. Some complex system synchronizers are part of the system computer that performs many of the functions other than the system timing. Synchronizer function. Specific function of the synchronizer is to produce the trigger pulse of the circuit of the transmitter, indicator, sweep the circuit of the arranging circuit of the time control is the function of the majority of the circuit of the radar, the circuit of the radar set. They accomplish with the control of the timing function, produce the variety of the voltage waveforms, such as the square wave, the sawtooth, the trapezoidal wave, rectangular wave, brief, the rectangular pulse, the sharp peak. Although all of these circuits are can be broadly classified with the timing circuits. Specific function of the individual circuits can also be wave shape of the wave generation and operation of many of these circuits are associated with the term of the detail of each module line, wave generation, and wave shaping circuits. Synchronizer operated with the radar system may be classified as self-synchronized, externally synchronized system, the self-synchronized system with the time trigger with the pulse, the generator with the transmitter with the externally synchronized system, timing trigger, and pulse with the generator with the master oscillator, which usually external of the transmitter. The master oscillator externally the synchronized system may be the blocking oscillator, sine wave, the oscillator, a stable, free running multiple vibrator. When the blocking oscillator, usually the master oscillator, time trigger, the pulse is usually obtained directly from the oscillator. When the sim wave of the oscillator with the astable multi vibrator, you have the master oscillator with the pulse shaping the circuit that is referred to in the form of the necessary timing trigger pulse is externally synchronized with the radar system pulse repetition rate with the timing trigger pulse with the master with the oscillator with the pulse rate repetition rate. Transmitter self-synchronized radar system with the pulse repetition rate with the trigger timing with the pulse determined by the pulse repetition rate with the form of the modulator with the transmitter associated with every radar system is an indicator such as the cathode ray tube associated with the circuitry. This indicator became present with the range of the bearing, the elevation down with the visual form of the image so that the detect of the object would be located with the trigger pulse with the synchronized frequently either the gate or enable the pulse to apply with the indicator gate pulse to perform the following functions. Initiate with the time duration indicator sweep voltage intensify with the cathode ray tube electron beam during the sweep with appear with each of the pulse may be displayed to generate the range of the marker generated over the range of the marker signal that must be superimposed on the indicator with the representation. Figure 2.1 show the typical type of the relation of various waveforms. Typical radar set with timing the trigger is applied with the bolt of the transmitter indicated with the trigger pulse is applied with the transmitter short burst of the transmitter pulse of the radio frequency energy is generated. Show the timer trigger the pulse of the transmitter pulse with the echo pulse of the receiver output of the indicator sweep of the voltage sweep time flat back time indicator intense gates pulse for the range mark gate pulse the range marks video signal to the indicator time interval 1 and 2 and voltage is positive negative and 0. These energies conducted along the transmission line with the radar antenna, the radio with the antenna into the space, the transmitter energy is strike with one with more flexing object within path. Some of the transmitted energies reflect the back of the antenna with the equal pulse of the three reflecting target with a different range of the illustrated figure 2.1 with the echo of the converted with the corresponding with the receiver the output signal shown in the figure large initial final pulse with the receiver output with the signal coupled the energy leave through the duplexer above the pulse with its transmitter. The indicator sweep volts for the shown figure 2.1 initiated at the same time with the transmitter trigger with the other application that made more desirable delay timing trigger pulse with the be fed with the indicator sweeping circuit delay with the trigger pulse with the initiated with the indicator sweep after the pulse is transmitted. Note figure 5.1 with the positive portion of the indicator's intensity gate pulse applied with the cathode ray tube control grid occurs only during the indicator sweep time as a result of the visible cathode ray tube occurs during the sweep time and the eliminated during the flyback with the retrace time and the negative portion of the range mark with the gate with the pulse that also occurs during the indicator sweeping time. Negative gate pulse is applied with the range marker generated to retrieve the series with the range mark. The range marks are equally spaced for producing only the duration of the range marker gate. Both of the range markers are combined with the make of the receiver output signal, resulting in video signal applied with the indicator may appear shown in the bottom of the figure 2.1. Our basic synchronizing circuit. The basic synchronizing circuit should meet the following three basic requirements. It must be free zone and stable to be covered with the synchronizer however the radio. It must be established with zero time reference to the pulse repetition frequency or pulse repetition rate. Should be stable and frequent with the actuating of the pulse repetition rate with the reciprocal of the pulse repetition time. That must not be changed with the time between both. The frequency must be variable to enable the radio to operate with a different range. The three basic synchronizer circuit can be meet with above the mentioned requirement. The same wave oscillator with a single wave blocking oscillator. The master trigger is stable to multivariable. The figure 2.2 show with the block diagram waveform 3 synchronized that are used externally synchronized radar system. Each of these equally spaced timing trigger the pulse that produce the pulse repetition rate. Each series with the timing trigger pulse that determine the operating frequencies are associated with the master oscillator. Show the similar wave on the oscillator, synchronized similar wave oscillator, overdriven amplifier, RC differentiator limiter, the trigger pulse with the transmitter. And you show the multi-vibrator synchronizer to the indicator is adjustable multi-vibrator DC RC differentiator limiter trigger pole for the transmitter, and also your blocking oscillator with a single swing blocking oscillator to the indicator limiter with the trigger pole for the transmitter. Your sim wave oscillator synchronizes. The sim wave oscillator synchronizes. The sim wave oscillator is used with a basic timing device master oscillator output with the both of the overdriven amplifier with the radar indicator the sim wave applied with the overdriven amplifier are shaped in square wave. The square waves are converted into power with the negative timing trigger with the whole of the mean for the short time constant or of the RC differentiator. The mean with the limit for the either positive with the negative trigger with the pole for the RC differentiator with the remove with the leave with the trigger with the pole for the only one parallel for external. The limiter view A with the figure 2.2 with the negative lobe with the limiter of this is limited remove with the negative trigger with the pole with the passes only power with the trigger pole with the radar transmitter. The disadvantage of sim wave oscillator synchronize the large number of the pulse shaping circuit required to produce the necessary timing trigger pulse. The master trigger and A-stable multi-vibrator synchronizer. Master trigger there A-stable multi-vibrator synchronizer figure B view B figure 2.2 with the master oscillator generally a stable multi-vibrator. The multi-vibrator asymmetrical, symmetrical, the multi-vibrator, the asymmetrical generated with the rectangular wave, the multi-vibrator symmetrical is generates the square in either case with the timing trigger to pulse the equally spaced with the limit remove with the undesired pop with the negative lobes. The transistor with the A-stable multi-vibrator 2 output voltage with the equal with the amplitude of the 180 degrees out phase output of the A-stable multi-vibrator with the positive negative of the rectangular wave of the rectangular waves are applied with the RC with the differentiator with the converted with the positive with the negative of the trigger pulse with the same wave synchronized with the negative trigger pulse with the remove with the mean for the negative of the lobe limiter positive the pulse are applied with the transmitter the positive of the negative of the rectangular wave to A-stable multi-vibrator applied with the indicator one side of the wave that even intensify the cathode ray tube the electron beam with the duration with the sweep. Other set wave that are used to gate with the turn on the range marker generator. Or your single swing blocking oscillator synchronized with a single swing blocking oscillator synchronized with the shown figure view C with your 2 with the free running with a single swing blast oscillator generally with the master oscillator. The advantage of single sweeping and blocking oscillators generates sharp trigger pulse with additional shaping circuitry. The timing trigger pulse with the only one with the polarity to obtain with the mean with the limit of the gating pulse with the indicator circuit that produces the applying with the output of the blocking oscillator to a one-shot multi-vibrator. Any of the variable time delay circuit that is not shown with crystal controlled oscillators may be the very stable frequency operations required. Transmitters produce with a short duration, high power radio frequency pulse with the energy rated with the indisplaced by the antenna. Two main types of the transmitters are known. The common use of the first for the key oscillator type transmitter, one state with the tube with the magnetron plate with the radio frequency pulse with the oscillator tube with the key with the high power with the DC pulse with the energy with the generator with the separate U then coupled with the modulator to cover the following section. Second type of the transmitter consists of the power amplifier chain with the transmitter system chain with the beginning of the radio frequency pulse with very low level power that is amplified by a series of the chain with the power amplifiers. High level power the desire for the transmitter plug is most powerful for the amplified transmitters. Each of the power amplifier stages is multiple modulated in a manner similar to the oscillator with the key oscillation type. Because the modulator is common both the type of the transmitter system and the operation of the typical modulator that discussed first. The radar modulator. The modulator controls the radar pulse width with the mean with the rectangular DT pulse the modulator pulse with the required duration amplitude the peak of the power transmitted the radio frequency pulse the dependent on the amplitude of the modulator pulse. Figure 2.3 show the waveform of the trigger pulse applied with the synchronizer to the modulator pulse applied with the radio transmitter with the radio frequency pulse. Show the trigger pulse from the synchronizer applied with the modulator modulator pulse applied with the transmitter and transmitter radio frequency pulse. As you can see with the figure with the modulator applied with the transmitter instant with the modulator receive with the trigger pulse with the synchronized time interval 1, 2 with the modulator pulse is pulse flat on the top of the head and deep in the landing, leading and the trailing edge of the pulse were character for the nature of the property operate the transmitter accurate determination of the target range of the ranging time we took with the most speed the instant leading with the edge of the transmitter the radio frequency lead with the transmitter in this way with the trigger pulse the control of the operation of the modulator also synchronized with the cathode ray tube sweeping circuit with ranging measuring circuits. Magnetron oscillators are capable of generating radio frequency pulse with a very high power for add with the frequency range of the 600 330,000 megahertz with the however the cathode rate voltage chain with the magnetron oscillator shift the frequency with the void with the frequency change. You must ensure with the amplitude of the modulator DC pulse with the remaining constant with the duration transmitted the radio frequency pulse. This is the modulator pulse that must have the flat top of the remember the cathode voltage over the magnetron oscillator with the desired frequency spectrum relatively small. When the low voltage is applied with the magnetron produces the noise voltage output instead of the oscillation the noise at the edge of the receiver that can completely map the return echo the end modulator builds up the case slowly with the noise then produce the head both being an end of the pole, therefore efficient radar operates the magnetron reduce it require the modulator pole with the flat top of the cheap leading trailing edge the effect with the modulator pole with the must perform in the following manner that provides from the zero with the maximum value with the almost time instantaneously remaining maximum value with the duration of the transmitted radio frequency pole falls to the maximum zero almost instantaneously. Alright, the radar is required the accurate range measurement of the transmitted of the radio frequency pulse the must have the cheap leading with the edge of the leading edge of the echo. The achieve the range measurement of the leading edge of the echo is not the cheap then clearly defined with the accurate range of the measurement is not top of the leading or trailing edge of the echo with the same shape as the leading and trailing edge of the transmitted radio frequency pulse. A transmitted radio frequency steep trailing edge of the essential for the detection object for the short range of the magnetron output voltage drop gradually with the maximum value to zero that contribute the very little to the usable energy transmitted by radio frequency pulse. Therefore, furthermore, the magnetron output voltage at either end of the receiver obscure nearby object echoes. Type of the modulators. Two type of the modulators are line pulse modulator, hard tube modulators, hard tube high vacuum electron tube. The line pulse modulator stores energy in the form of the pulse of the same circuit element. The elements usually pulse forming network. Hard tubing modulator form of the pulse of the driver, the pulsing amplified with the modulator. The hard tube modulator has been replaced with the line pulse modulator in most cases. This is because the hard tube of the modulator has low efficiency. The circuits are more complex. The high power with the supply voltage is required to move. The more sensitive the voltage changes. Line pulse modulator is easier to maintain because of the less complexity of circuitry. Also, for the given amount with the power output with the higher, the more compact. Because of the principle of the modulator modern radar is the only type of the will be discussed. Figure 2.4 show the basic sections of the radar modulator that is followed the power supply storage element, circuit element of the network used to store the energy. The charging impedance that use the control of the charging time the storage element to prevent the shorting circuit of the power supply during the modulator pole with the modulator switch. Use the discharge energy stored with the storage element through the transmitter oscillator during the modulator pulse. Figure A show the modulator switch open the storage eliminating charging power supply charging impedance. A modulator switch break and then the storage element transmitter. Your modulator switch close the storage element discharging power supply charging impedance the storage element transmitter. View of figure A on the figure 2.4 show the modulator switch open the storage element the charging with the modulator switch open the transmitter produces no power output the storage element large for the amount of the energy. View B show the modulator switch closed the storage element discharging through the transmitter the energy stored with the storage element relieved into the form of the high powered DC modulator piece pulse. Transmitter converts the DC modulator pulse at the end to an A radio frequency pulse which radiated into the space of the radar and temp of the modulator switch with the close during the transmitted the radio frequency pulse but open between the pulse with the many different kind of the component of the radar modulator power supply generally with produce the high voltage output either alternating direct current with the charging impedance may be a resistor and inductor. The storage element is generally compatible with the artificial transmission line and pulse forming network of the modulator which is usually modulator storage element. The capacitor storage element of the modulator have the DC power supply with the electron tube modulator switch. The capacitor storage element is charged with a high voltage by the DC power supply relies only on a small part of the storage energy to the transmit by the electron tube. The modulator switch control of the charging and discharge of the capacitor storage element. Artificial transmission line or storage element is shown in view A with figure 2.5 showing the diff of the identical capacitors and inductors arranged with a simulate with this section of the transmission line. Artificial transmission line serve with the two purposes of the storage energy of the modulator switch open between transmitter radio frequency pulse and two the discharge of the rectangular DC pulse with the modulator pulse over the required duration of the modulator switch closed. Artificial transmission line capacitors and inductor currents of the modulator storage elements, capacitors and inductor currents, modulator store elements, and the duration the modulator, the pulse dependent of the value of the inductance capacity of the LC section of the artificial transmission line of the view A and the view the number of the LC sections of the other arrangement of the capacitor and inductance of the pulse forming network shown in view B are very similar operation to artificial transmission lines. Artificial transmission lines, pulse forming networks are used more than often the capacitor type storage. Artificial transmission line, figure 2.6 show the radiator modulator, use the artificial transmission line, the storage element modulator switch control of the pulse repetition rate with the modulator switch open between the transmitted with the radio frequency with the transmission line charges. The show of the modulator of the artificial transmission line storage elements. You have the charging impedance module with the artificial transmission line pulse transformer, the radio oscillator switch charge path, discharge path. Charging path includes the primary with the pulse with the transformer, the DC power supply with the charging pump, the modulator switch with the globe with the transmission line, discharge with the root of the receiver with the circuit. The circuit consists of the modulator switch with the primary with the pulse transformer. Your artificial transmission line effectively opens for the circuit output and therefore with the voltage wave with the reach for the output end of the reflective wave with the propagate with the output with the end of the back of the input and of the line completely discharged with each of the section with the line with the reflected wave with the reach for the input with the end of the line with the line is completely discharged with the modulator pulse sheathed abruptly with the oscillator the pulse transformer circuit impedance properly matched to the line with the impedance voltage pulse with the appear with the curve of the transformer permanently equals 1/2 of the voltage of the which for the line that was initially charged. The width of the pulse is generated with the artificial transmission line depending on the time required for the voltage wave of the travel to the input end of the output end of the line back with therefore we can say with the pulse width depending on the velocity of propagation of the line along the line determine the inductance capacity each of the section with the number of the line section length of the line. Your pulse forming network with the pulse forming network similar to the artificial transmission line with the storage end between the pulse with the nearly rectangular pulse with the pulse forming network with the view B with the figure 2.5 the shift of the inductor capacitors certain range of the approximate behavior of the artificial transmission line each capacity of the artificial transmission line shown in view A with the must carry with the high voltage required with the modulator pulse. Each of the capacitor must be insulated with a high voltage of the artificial transmission line consisting main section would be bulky and conform some of the pulse forming network shown in view B with the figure 2.5 the carry with the high voltage but does not require bulk insulation of all the capacity of the only share of the capacitors capacitor 1 must have the high voltage insulation because the other capacitors are in parallel with the corresponding capacitors modulator pulse voltage divided nearly equally among them. Thus the capacitor 1 elements to pulse forming networks are relatively small. Pulse forming networks are often insulated and immersing each of the circuit of the element in oil. The network is usually included with a metal box on which the pulse with a characteristic impediment to save the operation voltage network are marked with one element of the shunt of the network failed, the entire network must be replaced. The modulator switching device. The voltage stored with the storage element of capacitor artificial transmission line pulse forming network that must be discharged through the modulator switching device. Modulator switching device can over the duration modulator part with the open circuit between the pole with the dust. The modulator switch must perform the following 4 functions. Close very quickly reach of the full conduction with a small fraction of the microsecond conducts a large current with a 10,000, 10 or hundreds of the amperes with a stand with a large voltage with 1,000 volts. And cease the conduction between becoming an open circuit with the same speed with the start of the conduct. Consume only a very small fraction of the power that is passed through it. The switch conduction requirement that must be met with a thytron tube. The thytron tube is normally held below with the cutoff with the negative grid of voltage for the conduct with the positive trigger pole with the apply with the grid that once fire with the thytron tube continue with the conduct along as the storage element with the artificial transmission line pole within the form of the network is discharged. During the discharge of the storage element of the gas thytron tube, slightly ionized while the storage element discharge the plate with the cathode resistant with the hydratron is practically distributed while the storage element completely discharged current ceases the flow with the hydratron gap at the becoming deionized negative grid with the regains control of the hydratron is called with the modulator switch open. The most radar modulator high voltage DC power supply. The DC power supply with the radar modulator half wave rectifier, full wave rectifier, or bridge rectifier. The modulator charter impediment with the shown figure 2 plus having them prevent the DC power supply with the becoming short circuited with the modulator switch closed. The modulator switch is open with the charging impedance to all control of the rate for the storage element and charge with the charging impediment small with the storage element charges rapidly. Shows the 2 steps of the modulator charging impediment. The DC power modulator switch the transmitter and the storage element and the charging impediment. The resistor many difference over the charging impediment, the charging the impedance circuit of the radio modulator of the 2 type of the charging impediment, the charging circuit of the dependent on the following 5 elements, the type of the power supply AC or DC, the type of the storage element, the amount of the modulator pulse voltage required with the pulse repetition rate, the frequency of the available AC supply voltage. Your key oscillator transmitter, the key oscillator transmitter opens up the magnetron with the power oscillator with the following discussion. Describe the magnetron with the key oscillator radar transmitter. Figure 2H of the typical transmitter system with the magnetron oscillator waveguide, the transmission line microwave, the antenna with the magnetron at the bottom of the figure is connected to the waveguide with the coaxial connected with the high power with the magnetrons out with the usually coupled together directly to the waveguide with the cutaway with the typical waveguide coupled with the magnetron shown in figure 2.9. Show the antenna with the antenna feed, the iris, the rotary joint, the 90-degree E-band with the iris, the direct coupler with the 90-degree E-band with the choke joint waveguide slotted section ATR device, DR device, receiver input circuit with the intermediate frequency output, local oscillator, and magnetron oscillator. This show the arbitrary waveguide attaching flange to the cathode cavities, anode block cooling fans, and permanent magnet. Typical magnetron. The magnetron electron tube with the magnetron H field between the cathode and plate with the perpendicular to the electronic field. The tube circuit with the form of the cylindrical cavity of the plate with the produce the radio frequency electrical fields. Electrons interact with the field of the space between the cathode and plate with the produce the AC power output. Magnetron function self-described the microwave oscillator, the multi-cavity devices that may be used with the radio transmitter for the either pulse or continuous wave oscillators. Frequencies range with approximately 60 to 330,000 megahertz. If you wish to review the magnetron operation in more detailed, these modules will have the microwave principles. Let's explain the following characters of the magnetron view of the pulse radar transmitter, oscillator stage, stability, pulse characters of the magnet of the output coupling, stability, speaking of the magnetron, oscillator stability, the stability of the mode of the operation of the magnetron. Two main type of the modulators: the mode, skipping mode, shifting mode. Skipping is often or misfiring is a condition of the magnetron fire with randomly undesired, interfering with the mode duration. Some of the multiple times, not in others. Pole character for the tube noises are fault factors. More skipping, mode shifting, and condition is the magnetron chamber with one mode with another mode. Pulse time with the highly undesirable does not occur with the pulse modulator pulse with the proper shape and the length of the cathode magnetron is very poor condition. Your pulse characteristics are makeup of the high voltage modulator pulse with applied with magnetron. The pulse have the steep light leading out of the flat top of the steep trailing edge. If the leading edge is not steep, the magnetron may begin with the oscillate before the pulse reaches the maximum level. Since the lower power oscillation will occur with a different mode, with the demo with the method magnetron will be shifted the pulse to reach for the maximum power. Mode shifting will result with the undesired magnetron output. For some reason, the preventing mode shifting top of the modulator output pulse should be flat as possible. Variation applied with the operation power will be covered the variation of the mode of the operation. Trailing edge of the pulse should also be stable at the same rate to prevent mode of the shifting magnetron. Or the magnet. The proof of the magnet produces the fairly uniform magnetic field with the desired value of the interaction between the space of the cathode and plate with the magnetron. The strength of the magnet is critical for proper operation. Critical for proper operation. Magnetic field of the strength of the high and the magnetron will not oscillate. If the magnetic field strength is too low, the plate with the current will be excessive. Power output will be low, and frequency operation will be effective. The signal of the strength of the magnet with the critical, you should be careful with the handling of the magnetic strength of the magnet. Especially for ferromagnetic objects misaligned with the molecular structure of the magnet, decrease the field of strength of the output coupling. Output coupling transfer of the radio frequency from the magnetron with the output transmission line with the coaxial line with the waveguide with the number. The conservatization improve with the input, the restriction upon the output of the circuit with the wavelength with the frequency power level with the magnetron. The output of the energy determine whether the transmission line is and will be waveguide coaxial line. Coaxial output with the circuit conservative the length of the coaxial line with the concern with the conductor shape of the into the loop conservative one with the magnetron cavity magnet coupling. Loaded side of the coupling made with either the external coaxial line with the waveguide, the external line with the coaxial with the connection may be direct with the mean with the choke joints. The external line with the waveguide output with the circuit that may be included with the satisfactory joint with the coaxial line with the waveguide. One type of the junction, then you with the quite often you with the probe coupler acts with the incident reading edge of the waveguide output may be fed direct with the opening of the slot. The one with the magnetron cavity shown figure 2 down with the opening must be converted with the iris of the window to maintain vacuum seal. The peak power rating for the magnetron ratings of the few thousand watts to several million watts or megawatts. The average power rating of the much more low. However, the very few watts to several kilowatts. Additional many with the magnetron with the modern radar system tunable with the frequency typical tunable magnetron can vary with the output frequency of plus or minus 5% about with the center of the frequency band thus carrying the frequency with the radar can be chained with obtaining the best operation with the avoid electronic jamming particular frequency modulator signal many with 1,000 volts is applied with the magnetron cathode during operation of the high voltage level require less large glass post for the insulate with the cathode filaments or the anode block with the high power of the magnetron of the cathode is completely enclosed with the container filled with the insulating oil. Warning, all radar transmitter containing lethal volts with extreme care with the trick of the observance of the posted safety precautions essential to working with a radar transmitter. Powerful amplifier transmitter. Powerful amplifier transmitter use the many with a recently developed radar system. The type of the transmitter developed with the more stable operation of the moving target indicators MTI. Magnetron transmitter system, high power magnetron oscillator have the tendency to drift in the frequency because of the temperature variation chain with the modulation pulse vary other effects. Frequency drift is accommodated with the part of the automatic frequency control with the circuit is designed with the control of the frequency with the local oscillator with the receiver system. This is however it does not completely eliminate the undesirable frequency with the drift of the MTI operation. Power amplifier transmitter simply does not seem So the same thing with the key oscillator transmitter, but the viewer sensibility a problem with generally shape of the amplifier, pulse of the radio frequency energy for transmission. Figure 210 shows the block diagram, typical power amplifier transmitted with the transmitter system, multiple cavity tube amplifiers, low power power to radio frequency pulse with the generator with the shape of the and one other stages of the crossfield, the amplifiers, the amplitrons, or the radar system, while the wideband transmitted frequencies because they are stable over the wide frequency range. The crossfield, the amplifier transmitter discussed later in the section. The local oscillator of the continuous wave, the radio frequency signal, the two-way buffer, the receiver, the mix amplifier. Your system triggers the COH oscillator, the low voltage modulator, high voltage modulator, mix amplifier, first intermediate amplifier, second intermediate amplifier, clash power amplifier, radio frequencies to the antenna. Figure 210, power amplifier chain with the input signal with the generator with the hydrodynamic, the two frequencies, the two different frequencies are fed with the mixer stage, and the mixer amplifier result when they either some of the difference frequency may be selected as an output. Operation of the mixer receive uncirculated in more detail with the section with the receiver of the lower ports, power pulse. Is amplified by the intermediate power amplifier stage applied with the collection power amplifier. The collection power amplifier concentrate the radio frequency output energy with the very narrow frequency spectrum. The concentration that make the sync system more sensitive with the smaller target. In addition, with the detection range of alpha targets increase. To examine the operation of the transmitter will trade with the signal with the entire trade circle the local oscillator shown on the left with the figure 210 with the variable radio frequency oscillator with the produce the continuous wave radio frequency output shown with the continuous wave output. The same with the receiver system the continuous wave output is also one of the two radio frequency signal with the effect that is mixed amplifier by the way of the two buffer amplifier stages. Both of the amplifier raise the power level of the signal also isolated the local oscillator. The coherent oscillator or COHO is triggered with the system triggered to produce the output with the radio frequency oscillator, the radio frequency pulse with the fed directly with the mixer amplifier. Mixer amplifier state with the receiver the three signal with the coherent radio frequency pulse with the local oscillator continuous radio frequencies signal with the DC modulating pulse with the low voltage modulator. The coherent local oscillator signal mix with the produce the sum of the difference frequency signal. Either they may be selected as an output modulator pulse with the server is the same purpose the key oscillator transmitted because it determines the pulse the width, the power level, the maximum mixed stage function. Only generating the modulating pulse at the time of the mixer amplifier produces the output with the radio frequency pulse with the frequency may be either some of the difference coherent local oscillator signals. The mix amplifier feed the pulse the radio frequency and the intermediate power amplifier. The amplifier stage similar with the buffer amplifier except for the pulse amplifier with the pulse amplifier was high operating power with only during the time of the modulator pulse with the low voltage modulator applied with the stage. Amplified output signals fed with the second intermediate power amplifier operates the same manner with the first. From the second intermediate power amplifier the signal is key fed to the collectron power amplifier, the shade of the multi-cavity power collectron with the input of the radio frequency is used with the auxiliary signal with the first cavity of the high voltage modulating pulse with the high voltage modulator applied to the collectron power amplifier. High voltage modulating pulse with the stepped up with the curve of the pulse the transformer before being applied with the collectron. All cavities of the collectron are tunable and tuned for the maximum output with the desired frequency. Provisions are made with the type of the transmitter for the starting type of the modulating pulse applied with the coherent oscillator mixing amplifier, intermediate power amplifier, collectron power amplifier. This means by millions of various modulators are made to the curve at the same time transmitter produce the output of the radio frequency with the constant power of the medium frequency modulation ensure the good performance. Figure 211 shows the block diagram of the power amplifier transmitted with the frequency synthesizer to produce the transmitted with the frequency rather than the heterodynamic for the frequency synthesizer allow the transmitted to radiate large number of the discrete frequency with over large relatively wide band. Such systems commonly with the frequency scan and such radars are most transmit many of the different frequencies of each of the elevation coverage of the concept of the roll and pitch of the ship. Show the synchronizer, the frequency selector gave the frequency shift over the first radio frequency amplifier, second radio frequency amplifier, first stage modulator, second stage modulator, high power voltage, third stage modulator, third stage radio frequency oscillator, amplifier. Type of the frequency synthesizer consists of the bank of the oscillator produced with the different frequency of the frequency output of the relative of the few fixed oscillators can be made with the various combinations that produce the wide frequency of the MTS. If the select with the oscillator frequency, they mix with the coherent oscillator with the frequency, they provide with a stable oscillator reference for the MTS with the frequency stable synthesizer also produce with the local oscillator synchronized the receiver shift the become of the transmit with the whole chain with the frequency with the ease of the transmission local oscillator signal and receiver that must be also changed and due to the transmitted frequency of the system of the type of the frequency program the selected gate signs from the synchronizer. The detailed operation of the frequency synchronized with the beyond the scope of this being able to may be defined with the technical meaning of the most common frequency scan radar system. First with the radio frequency amplifier receive the pulse with the selected frequency with the synthesizer of the modulator pulse with the firm the first stage modulator at the same time the radio frequency pulse usually slightly wide with the modulator pulse to prevent the amplifier tube with the pulse with no radio frequency energy with the spread with the most radio pulse radio frequency amplifier oscillate with the undesired frequency pulse with the radio frequency input with the output over the first radio frequency amplifier amplify the radio frequency pulse with the same width of the first stage the modulator pole for the second stave of the modulator, designed to produce the pulse slightly narrow for the first stave of the modulator pole, but also prevent the amplifier for the pulsing no radio frequency of the present. Therefore, the second stage amplifier received the modulator pole for the short time on the first stave of the radio frequency after arrived at the input. As they shown in Figure 211, the same procedure, the repeat with the third and final stave of the amplifier type of the power amplifier transmitter must be broadband and wide breakaway amplifier to amplify input signal with the frequency distortion typical of the first stave, the second stave of the traveling wave tube of the final stage of the cross-field amplifier. Recent technology, the field state of the microwave, the amplifiers have produced the solid state amplifier, each with enough of the output to be used. First state, some system transmitters more than 3 stages of the usually cross-field amplifier, third, and any additional stages, both traveling wave tubes, cross-field amplifier, very flat application respond with a relatively wide frequency range. Your cross-field amplifiers have another advantage when you use the final state of the transmitter. The design of the cross-field amplifier allows the radio frequency energy to pass through the tube virtually and unaffected with the tube does not pull with the no pull with the present with the tube that acts with the section of waveguide. Therefore, the less the maximum output of the power is desired in the final preceding cross-field amplifier states can be shut off when is needed. Feature also allows the transmitter to operate reduced power even with the final cross-field amplifier is defective. Alright, your duplexer. When a single antenna with multiple, with both transmitting and receiving the radar system problems arrive at the switching of the antenna between the transmitter to receive the mode of the present one problem, then ensure the maximum use of made available to enter these. Number the simple solution is the switch of the transfer the antenna connect the receiver to the transmitter during the transmitted pole to the receiver during the return echo pole. There's no practical mechanical switches available that can open and close with a few microseconds. Therefore, the electronic switches must be used. The switching system typical type of the complete duplex. The duplexer when basic duplexer operation. Selecting the switch of the task, you must remember that predict from the receiver the input, the circuit the input with the output power considerization frequency with the amplifier, maybe with the amplifier tube with the show with the withstand with the large input with the powers without damage. However, the input circuit with the receiver that is easily damaged with the large amplifier. The signal must be carefully protected. The defective radar duplexing system must be meet the following 4 requirements. During the period of the transmission switch must connect with the antenna with the transmitter. Discover the for the receiver. The receiver must be thoroughly isolated with the transmitter during the transmission with a high power pole for the avoid damage of the sensitive receiver. The component after the transmission switch must be rapidly disconnect the transmitter connect with the receiver to the antenna for the target scope of the radar to be seen with the action of the switch must be extremely rapid, but the switch should be absorbed with the absolute minimum power both of the transmission and reception. Therefore, the radar duplex with the microwave equivalent of fast left of the signal pole with the double throw switch. The device developed the purpose of the as are similar to the spark gap in which the high current of the microwave discharge of the furnace flow and penetrative path of the duplexer usually contain two switching tubes. Spark gap is connected with the microwave circuit with the 3 terminal transmission lines, one of each for the transmitter receiver. The antenna shown in figure A and B with the figure 212. The circuits may be connected with the parallel in-series both system. We'll discuss in detail circuit with the 1 and 2 with the call with the transmitter, receiver tube with the TR tube, other call with the anti-transmitter tube, their ATR tube, and the transmitter receiver tube has a primary function with the disconnect with the receiver and the anti-transmitter receiver tube, or tube of the disconnecting of the transmitter. So the transmitter air spark gap, the parallel, the receiver, the antenna, the transmitter receiver tube spark gap. Transmitter air spark the antenna transmitter's receiver spark gap receiver. The overall action of the transmitter and the anti-transmitter receiver circuit that depend on the impedance of the connector for the quarter length with the section of the transmission line, quarter wavelength with the odd multiple with the quarter wavelength of the transmission line present on the opposite of the impedance with the value with the end of the one end of the line appear with the short, the other end of the appears as open. Your transmitter receiver tube, the type of the spark gap that you with the transmitter receiver the tube may vary with the one with the simply forward with the 2 electrodes. Play with the curve with the transmission line made with the 1 enclosed with the evacuated glass with the envelope with the space each for the improve of the operation. Where the spark gap of the 1 high impedance with the power of the arc with the very low and the impedance during the arc the time at the end with the transmitted pole of the arc should extinguish by the very rapidly positively extinguish of the arc stop the loss of the call of the arc with the permanent signal with the nearby target with each of the receiver to the receiver. Simple gap formed by the air with the resistance during the condition of the 30 the 50 but this is usually high for the ending with the opening wire transmission line. The time required with the air surrounding the gap completely deionized after the pulse voltage has removed the bout with the 10 microsecond during the type of the gap with the encrypted resistance across the transmission line which is connected with the with the transmission receiver system the air gap with the equals echo signal with the receiver the beyond with the gap of the will permit the increase of the half of the proper the magnitude of 3 microseconds after the pulse of the voltage had to move the interval known as the recovery time. Your transfer receiver tube is usually conventional spark gap with include with the partially evacuated seal gas envelope shown in figure 213 of A. an arc foam with the electron with the conductor of the ionized gap, the vapor, the volume, lower the magnitude, the voltage, and they break down the gap, the reducing the pressure for the gap that surround with the electrode, the optimum pressure they achieves most efficient with the transmission receiver operation. You can reduce the recovery time of the ionization time of the gap, and introduce the water type, the vapor, the transmission receiver, the tube, the transmission receiver, the tube that contains the water vapor, the presence of 1 millimeter of the mercury will recover of the 0.5 microsecond within the the transmission receiver, the tube that have the short recovery time, the reduce the range of the waves of the target. You have the radar can be detected. If an example of the echo signal should reflect with the nearby object return with the radar before the transmitter resistor tube, transmitter receiver tube that recover the signal that will be uncovered the ends for the receiver. Keep alive the electrode main gap, the negative 1000. Keep the alive voltage, DC ground, transmitter receiver. Keep alive the electrode. Alright, transmitter receiver tube, the microwave, the frequency that built up and then tube that become the part of the resonant cavity, become the increase the speed with the gap, and break down with the transmitter 5 with the place for the voltage, cover the gap, electrode with the potential with the zone with the keep the live voltage, from 100 volts to 1000 volts with the glow. Discharge of the maintain with the between the electrode of the terminal of the glow, discharge of the refer of the discharge of the electricity below the gas filled with the electron tube, the string with the by the cathode glow with the voltage drop with the higher gas ionization bolt of the cathode vicinity with the action provided with the rapid ionization from the transmitter pulse where it arrives. With the transmitter receive the tube with the primarily cover the two back with the first combo come with the cover with the failure with the gradually building up the metal particle with the dislodge from the electrode, some of the metal bits become separate splattered with the inside of the glass envelope of the particle with some of the conducting air with the 10 with the lower merit resonant cavity dissipate with the power of the tube to continue to use it with the too long and pure with the condition of the particle with the form of the tuning the wall with the cavity with the eventually preventing with the tube for the functioning second cover the failure with the absorbing the gap of the enclosure of the manual electrode, the resulting gradually reducing pressure of the tube point where the gap in the breakdown will become very difficult to final result with the extremely strong signal of the transmitter. They are coupled to receive the mobile type of the failure developed gradually transmitter TR tube periodically must be checked with carefully to determine the performance level. Your anti-transmitting tube, the anti-transmitting tube is usually simplified for the transmitter tube. The anti-transmitting tube that might use the pure in-air gas for the argon become with the recovery time of the generally not a vital factor for the furthermore primary agents have to keep it alive with the voltage not needed with the absence of either with chemically active gas to keep it alive with the voltage result of the anti-transmitting tube. They have a longer life use alive within a transmitting tube. The transmitter tube, the anti-transmitter tube may not contain radioactive material handled carefully to avoid break into possible contamination. Warning: there are two basic transmit receiver and anti-transmitter receiver. The duplex configuration, the parallel connected with the receiver that connect with the duplexer system. The following paragraphs describe the operation of both system. Parallel connected duplexer operation. The first law let's consider the parallel connected duplexer system shown figure 214 with the first gap. The shown figure 214 located with the receiver, the coupling line with the 1 quarter length wavelength of the T junction, the half wavelength of the closed end section transmission line with the stub. They are shown they crop the main transmission line. The anti-transmission tube spark gap is located with the 1 quarter of the wavelength for the main with the transmission line with the 1 quarter wavelength for the closed end with the stub of the shown figure antenna and pin for the line and pin for the transmitter output and the pin for the transmitter are equal to the action of the circuit during the transmission shown in the figure 215. So the transmitter, anti-transmitter receiver, sparking gap, the TG function antenna, TR spark gap of the receiver, reflected transmitter, anti-transmitter gap shorted, TG junction and junction transmitted, TR gap shorted. Alright, during the transmitting pole of the arc of the appear with the curve with the bulk with the spark with the cover of the transmitter tube, the anti-transmitter circuit with the transmitter receiver circuit the act shorted with the close of the end with the quarter wave stub with the circuit reflect for the open with the transmitter receiver, the anti-transmitter receiver, the circuit open with the main transmission line, note with the transmitted energy passes through the reflected open with the anti-transmitter stub. Use the receiver therefore all the transmitted energy of the is directed into the antenna. During the reception shown figure 5 joins figure 216 with the amplitude with the receiver that with the insufficient with the cover of the air cover of the either spark gap the anti-transmitter receiver the circuit is now acts with the full wave or acts as a halfway transmission terminated with the short circuit with the reflect with the open circuit with the receiver the T junction with the 3/4 wavelengths of away the receive echo the receive the open circuit with the direction of the transmitter. However, the receiver the input with the impedance match with the transmission line pin with the entire receiver the signal will give the receiver the minimum amount of loss. So for the transmission for 250 ohms, the anti-transmitter receiver the gap not arcing reflected open with T junction antenna with the received signal with the transmitter receiver the gap not arcing the receiver the short end series connect with the duplexer option. The series connected with the duplexer system shown in Figure 217. The transmitter receiver, the spark gap is located in one half of the wavelength with the receiver, the T-junction for the anti-transmitter receiver spark plug with the gap is one half of the wavelength of the transmission line with a three-quarter wavelength for the receiver, the T-junction during the transmitter receiver, the anti-transmitter receiver gap fiber. The series connect with the duplex system shown in Figure 218. Discover the short circuit that reflect with the series connection with the main transmission line with the one with the flat half wavelength away with the transmitter pole for the receiver, the low impedance with the math with the direction of the antenna does not go into the anti-transmitter receiver stub and receiver the transmitter with the receiver, the T-junction for the antenna, the T-transmitter receiver, the spark anti-transmitter spark gap the receiver. Reflected short antenna transmitter pole for the transmitter receiver, the gap, the anti-transmitter gap shorted and transmitter receiver. Alright, during the reception, either spark gap at the driver shown in Figure 219, the anti-transmitter receiver the act with the halfway stub of the terminal with the open and reflect the short circuit with the T-junction and three-quarter with the wavelength with consequently receiver the signal with the low impedance with the half of the receiver with the numb with the half of the receiver with the low with the transmitter circuit. Transmitter receiver the selected short antenna receiver the signal with the transmitter receiver the gap not arcing the anti-receiver the gap not arcing receiver. The duplexer type, the duplexer control for the main form of the resonant cavity coaxial system waveguides if the hybrid ring the semblance of waveguide and the hybrid duplexer remote for the common radar so they're able to cover the next circuit. The waveguide duplexer with the usually considered as a transistor transmitter receiver the tube, the transmitter receiver the tube, anti-transmitter receiver the tubes housed in the resonant cavity attached with the waveguide system and the one something with the resonant cavity transmitter receiver tubes made with the lab the waveguides either directly and indirectly of doing switching action with the indirect method that use the coaxial lines if the uncouple the coaxial line with the waveguide with the antenna. Large left with the incurred with the use of the coaxial line resonant cavity with a couple directly with the waveguide with the Figure 220 show with the direct method of the cavity transistor receiver transmitter receiver the switching of the waveguides if the waveguide terminate with the antenna with the one end of the shorting plate with each other the magnetron with the voltage probe to side of the waveguide transmitter pole travel with the guide with the move it into the transmitter receiver the back through the slot with the cavity build fill up the strong electrical field across the brakes gap with the breakers down with the tune the E-tune the cavity with the action effectively seal with the opening and pull it past with the pole and energy to the antenna. So for the transmitter tube the receiver line with the transmitter receiver back with the tune to the antenna with the guide with the coupling slots with the short end of the plate. Signal receiver the bed during the resting time of the travel during with the magnetron with the shorting the end of the plate with the reflect with the slot coupling with the waveguide with the cavity located at the point where the standing wave magnetic field produced the reflection of the waveguide within the maximum magnetic field therefore energy of the cavity equals signal they're not strong enough to cover the arc cavity field is undisturbed by the gap therefore the cavity field with a coupled radio frequency energy into the receiver the coaxial and provides the maximum energy transfer the cavity of the transmitter receiver the switch can also be applied with the branch line with the waveguide as shown in Figure 221 the magnetron is coupled with the guide with the voltage probe to produce the proper excitation. So the transmitter tube the resonant cavity air switch with the gap the switch to the pi divided by the antenna resonant cavity transmitter receiver the switch most the receive the signal with each over the anti-transmitter receiver the tube the transmitter pole for the travel the magnetron anti-transmitter receiver the branch will apart the energy with the diverted into the gap of the slot with the as for the place crowd with the waveguide with one half of the wave with the length of the band gap with the path of the radio frequency energy through but the into the cavity built with the electrical field breakdown with the gap G-tune with the cavity and result of the effect off the cause of the swap of the one half of the wavelength of the wave and this action effectively close the entry of the anti-transmitter receive the branch limits the amount of energy entering the anti-transmitter receiver branch in small value. Most of the energy therefore directed down with the guide with the antenna upon the reach of the receiver the brain with the same effect with the produce with the transmitter receiver the tube with the receiver line couple the energy entry for the both of the opening with effectively limited gap with the maximum energy transfer both between the magnetron and the antenna during the resonant time of the anti-transmitter receiver the spark gap that's broken down with the receiver signal the receiver sets up the standing wave of the cavity that cover the resonancy with the low impedance with the anti-receiver anti-transmitter receiver cavity is reflected the high impedance and transfer the transmitter waveguide three-quarter wavelength of the way ensure for the maximum receiver signal will enter the receiver branch. Alright, your hybrid ring duplex. The hybrid ring leads you for the duplex or hybrid power radar system. The very effective and isolating receiver during transmission. Simplified version of the hybrid ring duplex shown view A and B of the Figure 222. The operation of the duplex in terms of the even electric field distribution and the transmission reception illustrated view C and D and H line through the transmitter have been augmented with a simplified explanation. Show the hybrid ring top view. Transmission line reception during the transmission the electrical field with the transmitter in for the arm 3 with the divide with the two fields 180 degrees out of favor the outfield move the clock cloud with the realm of the ring, other move with the counterclockwise to the field with the 100 degrees, 80 degrees out of favor of the entry of the arm of the propagate with the energy down with the arm of the fielding, move with the clockwise for the arm of the 3 iron with the transmitter receiver tube of the arm, 4 with the energy block for the receiver, the transmitter receiver tube, the reflect with the high impedance equivalent with the open circuit. High impedance prevents any entry for the entering the receiver the entry, and even though the two fields are out of favor, the entry of the arm 4 field moving the counterclockwise with the arm 3 iron of the transmitter receiver the tube of the arm 2, which will reflect with the short circuit of the back of the ring conjunction. No energy same with the receiver that have the cover the field arriving at the arm 2 that are in favor. The clockwise counterclockwise fields arrive at the arm 1 out of the phase 100 degrees. They are propagated through the arm of at the antenna. Alright, during reception, relatively weak field of the antenna entry for the arm 1 with the junction, the 2 phase out with the component, with neither field with the justification with the transmitter, receiver the 2 with the arms 2 and 4 with the sympathy field arrive with these arm with the out phase, the energy is propagated with the receiver, the energy arriving in the arm 3 in phase will not be coupled to the transmitters from the operation of the arm with the hybrid ring, and same with the operation of the electro field type. We've got T junctions. You will find the helpful and of the module 11 microwave principles. Alright, receivers. The energy with the distance object with the reflect with the back of the antenna radar system with a very small fraction with the original transmitter with the energy echo with the return of the pole with the radio frequency and with the same nature with the center of the transmitter, how with the power with the return of the pole with the measure with the fraction of the microwatts instead of the kilowatt the voltage arrive at the antenna is range with the microvolts instead of the kilovolts with the radar receiver collect the pulse with the provide the visual display with the ejection of the information about the position object with the present visual with the reception of the echo system with the means for the appearing with the spotlight with the cathode ray tube, the crowd with the signal on with the order with the last several volts. Proper operation will not respond with the high frequency with the within and return pulse. Therefore, the receiver amplifier detector must be with the capable of producing the visual indication of the cathode ray tube under the following conditions: 1, with the input signal of the amplifier form with the pulse with extremely high frequency; 2, the amplitude of the pulse within its microvolt range, and the pulse over the last for only few microseconds. The radar involved with directly simple radio receiver. The radio receiver the operate with exactly with the same principle of the radio receiver that have the overall requirements limitation of the radio receiver that differ somewhat with those of the radio receiver that cover the high frequencies involved with the greater sensitivity of the desired. And so with the radar receiver, we will first examine the overall requirements of the radar receiver. The second, we will examine the typical radar receiver to satisfy the requirements. Finally, we'll discover the individual component of the receiver. Radar receiver requirements of the following character determine the radar design of the requirements of the effect of the radar receiver: noise gain, tuning, distortion, and blocking. The word noise carry over the sound of the communication equipment. The terminology of voltage sound of the equipment that produce the actual note of the loudspeaker output of the radar noise voltage result of the erratic random deflection of intensity indicator sweep with a small return signal. Where not for noise, the maximum range for the object with a detectable radar could be extended almost infinitely with the object with the greater with the return exceeding the small echo without noise. Almost any of the signal could be amplified usable level enough at the stage where to have the receiver to recover the noise at the single detection limit of the sensitive level to receive the reach for the signal level to fall off the low of the noise level to such an extent to be obscured. Small degree of the amplification on no help. The both signal and noise are amplified at the same rate in the radar portion of the radio frequency spectrum. The external source with the most interference with the usually negligible. Consequently, the sensitivity be achieved with the radar receiver, usually determined by the noise of the produced the radar receiver. Though not only must the noise be kept down with everything possible, must be done with a minimum of the actuation of the video signal echo is amplified. The gain of the radar receiver that must be very high with the peak over the string of the signal with the antenna level of the microvolt required with the output of the magnetic of the sublevel. The gain of the radar receiver that roughly range from 10 to the 6 to 10 to 8 of the feedback regeneration one of the most severe difficult design amplifiers such as the high gains. Special precautions must be taken to avoid feedback. This precaution include the careful shielding, decoupling, isolation between the voltage supply with a different tube, the amplification, different frequency, the type of group of the stages. Tuning the radar receiver that require with the limited tuning range of the compensating with the transmitter local oscillator frequency change with the variation temperature for the loading of the microwave radar receiver is usually automatic frequency control for the purpose. Distortion in the curve of the receiver, the time interval between the transmitted pole of the receiver, the pulse chain with the effective range of accuracy. Blocking refers to the condition of the receiver, the weight of the voltage, the pulse of the receiver input with the too large result of the short time after the pulse of the receiver, the insensitivity of the block with the signal below the certain level of the condition result of the one more with the amplifier stage. The receiver being overdriven within storage with a strong pulse of the receiver managed to be by with the point with which for the not amplifier. The small signals recover after blocking may only be the fraction of the microsecond and only may be several hundred of the microsecond depending upon the point of the receiver with the block occur with the detectable weak of the echo with the immediately following the strong with the receiver that must have a short blocking recovery time of the blocking itself with the may be minimized as much as possible. The proportion of transmitted pole with the leaks into the receiver input with the receiver must be blocked now not show with the small near objects and in most receiver the blocking minimize the locality with the duplexer prod check with the receiver in isolating during the transmitted pulse. Receiving block diagram. The super heterodyne of the receiver is almost always the microwave radar system is equal to the super heterodyne of the radar receiver that's shown figure 223. The receiver, the typical on type of the metal with the requirements listed above the single, the antenna, the receiver, the duplexer, low noise radio frequency amplifier, usually first state of the minor radar receiver. The sum of the receivers, however, the sum of the antenna is directly the mix of the shown with the dash path. Low noise amplifiers, usually the modern system, are usually solid state devices, tonal divided parametric microwave transmitter amplifiers. Figure 223 shows the typical super heterodyne radar system duplex for the low noise amplifier mixer first detector. I have the intermediate frequency amplifier video, second detector video amplifier, the indicator. You'd have your direct coupler output with the transmitter audio frequency AFC with the AFC with the amplifier, AFC with the discriminator control circuit with the automatic tuning local oscillator. Your mix stage often cover the first particular function with the shape of the converter with the receiver with the radio frequency with the lower the intermediate frequency with the they amplify the manipulating electronically intermediate frequency with the 30 to 60 omega for the obtained with the heterodyne receiver the signal the local oscillator signal the mixture stage convert for the receiver signal the lower and intermediate frequency with the distortion of the data of the receiver signal and after the conversion intermediate frequency the signal amplified several the intermediate frequency amplifier state with the most gain with the receiver that developed the intermediate frequency amplifier state with the overall bandwidth of the receiver that is often determined by the bandwidth of the intermediate frequency stages. The output of the intermediate frequency amplifier is applied to the second detector with the rectifier with the path through one of the more state with the amplification of the video amplifier output stage receiver with the normal the emitter with the file with the low impedance output with the emitter file with the branches impedance impedance of the cable of the video pulp coupled with the cable of the indicator of the visual display of the cathode ray tube. All super heterodyne receiver with the control of the frequency with the local oscillator keep the receiver tuned with the tuning of the critical sum in the form of the automatic frequency control with the essential with the avoid constant manual tuning the automatic frequency control circuit the mix for the actuated portion transmitted local oscillator signal to the form the intermediate frequency signal is applied with the frequency system and the sensitivity discriminator to produce the output voltage proportional amplitude with the polarity state change for the intermediate frequency with the intermediate frequency signal with the discriminator central frequency and discriminator output with the central frequency with the discriminator central with the reference frequency intermediate frequency signal the output with the discriminator provide with the control voltage maintain the low oscillator at the correct frequency. Direct receiver system may vary with the typical type of the coupling with between the state of the type of the mix with the particular low oscillator with the number of the shape of the amplification with the different frequency with the however the receiver that always designed to have little noise as possible designed to have the sufficient gain of the noise the lack of the gain limits of the smallest visible signal. Receiver the component of the section of the analog with the more detailed operation. Receiver the circuit with the bench and above the circuit of the discovered though usually found some form of the radar super heterodyne. Receiver the low noise amplifier some type of called the preamp with the found with the most modern radar. Receiver the previously mentioned for these amplifiers usually solid state microwave amplifiers. Most common type of the tunnel diode with the parametric amplifiers discovered in detail with the Neets module 11 the microwave principle. Some out of the older system most still use the traveling wave tube with the low noise one first stage amplifier with the solid state amplifiers power level the noise level the more gain. Local oscillators, most radar receive the 30-60 MHz the intermediate frequency produced it makes the local oscillator signal incoming signal the local oscillator, therefore essentially efficient with the operation for the both of the tuning and the variable state. For example, the local oscillator frequency the 3000 MHz the frequency with the 0 of 1/10 of the percent with the produce the frequency with the shift of the 3 MHz is equal to the bandwidth the most receiver will greatly reduce the receiver gain. Power output requirement the most oscillator small with the 20 to 50 milliwatts. We cover the most receiver the crystal mixers very little require very little power. The local oscillator output frequency must be tuned over the range of the several MHz with the 4000 MHz for each, and the local oscillator between to compensate for the any change of the transmitter frequency maintain with the constant for the 30 MHz 30 to 60 MHz the difference between the oscillator with the transmitter frequency with the local oscillator can be tuned with the very apply with the voltage that must be desired. The flexible klystron is often used with the local oscillator because of the means for the requirement that mentioned above. The flexible klystron is very stable. The microwave oscillator can be tuned to change the propeller voltage of the radar system is automatic frequency control the circuit to control the output with the local with the oscillator the block diagram the typical automated frequency control circuits include the figure 229 of the automated frequency control circuits are closed loop. The circuit in fact is called the automatic frequency control loop. A simple sample the transmitter energy for the field of the automatic frequency control next with the intermediate frequency the amplifier discriminator output with the discriminator DC air voltage for the indicator degree with the emission between the transmitter the local oscillator the particular example lets us from the intermediate frequency with the 30 MHz the output of the mixture correct with the discriminator will have no output of the mixture output with above 30 MHz the output of the discriminator will be power with the DC pole with the mixture output with the below 30 MHz the discriminator output will be negative DC pole. In either case, the output fed through the amplifier to the control circuit. The control circuit adjusts the operating frequency of the local oscillator so that no mistuning exists if the intermediate frequency of 30 MHz. For example, the local oscillator is the reflection klystron control of the circuit provided the repeller plate with the voltage of the klystron. Thus, the klystron directly control the local oscillator frequency in the main local oscillator, mainly maintain exactly 30 megahertz below the transmitter frequency. Right mixer. The many older receiver that do not use the low noise amplifier, but the receiver the front of it is simplified by the sending echo the signal directly with the crystal mixture of the state of the crystal and the tube of the rather than the electron tube at the top of the cup of the microwave frequencies. The tube would generate the excessive noise of the electron tube that you the limit of the effect with the transmitted time. Microwave frequency with the crystal most common with the point of the contact crystal diode, however, the recent development in the field of child state of the microwave device that may assume the replace with the contact diode with the device that produces even less noise with the Shakti barrier diode example is relatively recent developed to produce the less noise with the power of the contact crystal. This type of the radar system, radar makes the signal in with the unbalanced crystal mixture. If you don't figure 224, the mixer illustrates the tuned circle of the coaxial transmission, one half of the wavelength along with the second match of the crystal with the single echo of the local oscillator input. The local oscillator inject with the accomplished means for the coaxial assembly signal inject with the means of the slot. The normally interpret the duplexer waveguide assembly with the B properly oriented with provide with a couple of return signal the application unwanted signal output of the mixture carrier for the local oscillator frequency. Some of the two signals are effectively eliminated with the resonant circuitry tuned with the intermediate frequency when the advantage of unbalanced circuitry crystal mixture with some with one of the more disadvantages of the inability to cancel the local oscillator. No, the difficulty in detecting weak signal that exists with the noise is also allowed to pass through the mixer along with the signal. It shows connecting to the amplifier, the coupling with the radio frequency echo signal, the crystal local oscillator oscillation. If tuned not shown, one of the type of the mixers can the local oscillator known with the bandwidth and the hybrid mixer for sometimes called the magic key. Figure 225 show the type of the mixture for the hybrid mixer for the crystal with the insert with the direct for the waveguide with the crystal located with 1/4 wavelength through their respective short circuited wave end gap with the point of the maximum voltage all the way along with the tune line with the crystal with the also connected with the balance transformer, the circuit area in which the tunes are intermediate frequency local oscillator signal to introduce the waveguide local oscillator arm. The distributed itself is shown in A with the figure 226 with the local oscillator signal in favor with the crystal, the B with the echo signal that introduces the echo signal arm, the waveguide out with the A with the cross with the crystal, and the resulting field shown in C. Alright, so for the crystal, the magic key, the local oscillator, the crystal with the transformer and the capacitor to input signal with the echo in signal. You have your crystal local oscillator signal, balance mixture field with waveguide local oscillator arm. Your echo signal crystal and crystal balance mixture field waveguide echo signal storm crystal 1 and crystal 2 mixture base waveguide. In favor of the echo signal applied with the cross with the two crystals with the signal applied with the two crystals form the local oscillator for the in favor there are some of the form of the both signal applied with the crystal. Number 1 phase will be with the signal applied with the crystal. Number 2 will be out of favor. The means of the intermediate frequency of one polarity will produce with the cross with the crystal 1. The intermediate frequency with the opposite polarity with the property of the cross with the crystal 2. With these two signals will be amplified with the balance output with the transformer figure 225. They will be able to output with the same polarity with the control with the cancel with the cross with the balance transformer. The external limit is noise of the local oscillator noise of the component that introduced local oscillator the phase the cross with the control with the crystals R and R. They are cancel the balance transformer. The radio frequency character with the crystals may be nearly equal to the noise of the local oscillator will not completely cancel the noise. Only with the noise produced with the local oscillators cancel the noise arriving at the echo signal is not affected. Intermediate for amplifier state. The intermediate amplifier section of the radar receiver to determine the gain signal and noise the ratio of the effective bandwidth of the receiver. The typical intermediate frequency amplifier, commonly called the IF, the intermediate frequency strip, usually containing the 3 and 10 amplifier stages. The intermediate frequency amplifier capable of vary both with the band path of the gain with the receiver. The normally band path is narrow with the power affecting the actual signal energy. The selection of the pulse width available to such a short long pulse. The bandwidth must be able to match the bandwidth of two different signals. Gain must be variable to provide the constant voltage output of the input signal, different amplitude with 220 over the block camera, the intermediate frequency amplifier with the meet these requirements. Should the intermediate frequency from the crystal mixture for the first intermediate frequency, the second intermediate frequency, third intermediate frequency, narrow band with coupling, fourth intermediate frequency stage, wide band main couple the gain will control voltage. Most critical stage of the intermediate frequency section when the input of the first state of the quality of the stage determines if the noise of the figure with the receiver, the performance of the entire the receiver, the system, respect with the direct detection from the small object with the long range of the game with the band with only consideration for the design of the first intermediate frequency stage. Consideration perhaps the more important of the noise generation or the generation stage must be low, with the noise generated with the intermediate input with the intermediate frequency of the amplifier with the receiving stage must be exceed the echo signal in strength. Detectors, the microwave receiver, the strip of the converter with the intermediate frequency pulp of the video pulp, after the implication they are applied with the indicator, the simplified with the form of the detector, the one with the commonly with the microwave receiver, the diode detector. The diode detector circuit is shown the view A with the figure 228 with the secondary timing 1 and capacitor, transformer 1 and capacitor 1 2 with the circle the resistant intermediate frequency show echo pulse of the sufficient amplitude the shape of the volts for the developed the curve of the tune circle the intermediate frequency pulse with the shape of the its shape of the indicator with the dash line with the view B with the positive excursion E1 cover the no current flow through the die with however the negative excursion the result of the flow of the die current subsequent negative voltage to be the develop the curve of the resistor 1 and capacitor 2 between the negative peak voltage excursion E1 the E volt and the capacitor E2 discharge of the resistor 1 the E0 waveform of the negative video pole with the sloping edges and superimpose the intermediate frequency with the indicator with the outline view B with the negative polarity output with the output poles with the preferred with the positive pole must maybe the chamber reserving the connection from the diode with the view A with the inductance L1 inductance code 1 L1 combination of the wire capacity for the C2 with the low pass filter actuating intermediate frequency component of the waveform and voltage waveform result the minimum loss of the video high frequency components H of the from the amplifier transformer 1 capacitor 1, the voltage 1, capacitor 2, the resistor 1, voltage amplifier, inductor current, waveform diode detector. Alright, video amplifier, receiver the pulse of the detector, amplifier, the 3 pulse of the amplification, indication, the device, the video amplification, fundamentally resistor, capacitor, coupled with the amplifier, high gain with the transistor pentoids. However, the video amplifier must be capable of the relatively wide frequency to respond with the interaction with the electrode capacitance, radio frequency with the respond with the amplifier, the reaction with the coupler with the capacity with the diminished low frequency response. Problems with the outcome of the frequency compensation network, the video amplifier, the type of the frequency compensation network, there may be the video amplifier stage discussed in Neets Module 8 with the introduction of amplifiers. Receiver special characteristics. The performance efficiency of the radar receiver they often greatly decrease the interference of one or more of the several possible source of the weather. The receiver determine the most commonly interfere with the source of the especially the radar system. It operates at 3,000 MHz, but the unfavorable weather condition can completely mask all of the radar return of the render of the system unusable electromagnetic interference. The external source of the deliberate interference with the enemy, called jamming electronic countermeasure. They can also render the radar system many special circuits that have the design to help radar receive the counteract the effect of the external interference with the circuit of the video, with the enhancement feature for the anti-jamming circuit, the electrical countermeasure for the circuit. This section will discover the general terms of some of the most common video enhancements. Feature of the radar receiver. Automatic gain control the radar receiver. Some of the control overall gain with the involve the game with the one or more intermediate frequency amplifier of the main gain control by the operating of the simple method. Usually some of the more complex with the automatic gain control. Instantaneous automatic gain control is usually during normal operation. Gain control is naturally adjust the receiver, the sensitivity back for the receptors and signal the wide varying amplitude with the automatic gain control. Intermediate instantaneous automatic gain control is designed to shut off it's designed with a shut off feature receiver game that may be adjusted manually and if the manually gain control can be used to adjust the best reception of the particular signal. Simplest automatic gain control adjust the intermediate frequency amplifier by according to the in gain according to the average level of the received signal. Automatic gain is not even the frequency with the other type of the gain control because of the widely varying amplitude of the radar return signals. With the automatic gain control of the gain, it's control with the largest receiving signal. Several radar signals are being received simultaneously with the weak signal, may be the greater interest. The instantaneous automatic gain control is used frequently because they adjust the receiver of the gain with each of the signal. The instantaneous automatic gain control circuit is essentially a wideband DC amplifier and instantaneously control the gain with the intermediate frequency amplifier radio return the signal chain by the amplitude. The effect with the instantaneous automatic gain control they allow with the full amplification weak signal, the degree with the amplification strong signal, instantaneous automatic gain control limited out with the number of the instrument intermediate frequency with the state with gain control. The only one intermediate frequency stage is control of the range of the intermediate age and automatic gain control is limited to approximately 20 decibels more than in one stage intermediate frequency of the control. And instantaneous automatic gain control can be ranged increasingly approximately 40 degree decibels. Sensitivity time control. The radar receiver the wide variation in return signals amplitude must make adjustment of the gain difficulty, adjust the receiver of the gain for the best of the result of visibility near target the return of the signal without the best of the adjustment of the distance target the return of the signal the certainty of the adjust their amplifier gain with the time of the during the signal pulse the repetition over the period they call the STC circuits or sensitive time control circuits. Sensitive time control circuits apply with the bias voltage of the various time of the intermediate frequency amplifier with the control receiver the gain to the figure 220 show with the 229 show with the typical static to the sensitive time control waveform the relation for the translated and terminated pulse when the transmitter 5 with the sensitive time control circuit is agreed with the receiver the gain with the receiver that prevents the amplification of the leakage of the energy with the transmitted pulse and with the transmitted pulse the sensitive time control voltage begins to arrive at the end gradually increase with the receiver the gain with the maximum of the sensitive time control voltage effect with the receiver the gain usually limited to approximately 50 miles. This is because the closest target is most likely to saturate the receiver. The beyond 50 miles, with the sense of the charge control has no effect. The receiver operates normally. Transmitted pulse is maximum receiver, the minimum receiver, the sensitive time control voltage. Combination of sensitive time control and instantaneous automatic gain control circuit, the result of the better overall performance with either type of the gain control alone. With the sensitive time control decrease the amplitude of the nearby target return signals, while the instantaneous automatic gain decrease the amplitude of the larger than average return signal. The normal change for the signal amplified adequate compensate with a combination of instantaneous automatic gain and sensitive time control circuits. Anti-jamming circuit. The main of the circuit that overcome the effect of the jamming. The two important ones for the gave the automatic gain control circuit with the fast time constant circuit. The gated automatic gain control circuit that permits the signal with only for the very short time interval to develop the automatic gain control. The large amplitude pulse with the jamming. The transmitter arrive at the radar receiving. Anytime with the other during the gating of the period of the automatic gain control does not respond with these jamming pulse without the gated automatic gain control. The large jamming signal would cover the automatic gain control to follow the interfering signal that would decrease the target return signal and amplitude with the unusable value. The gated automatic gain control produce the output signal with only short time period. Therefore, the automatic gain control output voltage must be averaged over several cycles to keep the automatic gain control from becoming unstable. Your gated automatic gain control does not respond to the signal. The average arrival time is other than during the time of the target return of the signal. However, it cannot prevent the interference over the curves during the gating period. Neither can gating the automatic gain control prevent the receiver the overload because of the jamming the signal amplitude of the arc instead of the target of returning signal. This because of the desired signal, and it's gave it a series of the receiver game of the signal over the particular amplitude as an aid of the preventing radar receiver the signal for the overloading during reception of the jamming signal. Fast time constant coupling circuit the circuit to connect with the video with the detector output of the video amplifier input circuits. First time constant for the circuit, the differential for the circuit located with the input of the first video with the amplifier large block video the amplifier with the fast time constant for the circuit only for the leading edge for the will path. This is because of the short time constant for the differential for the small target will be the same length signal indicated with the large target. Because of the only one edge of the display of the fast time constant for the circuit, it has no effect on the receiver gain, although it does not eliminate jamming signal. The fast time constant greatly reduce the effect of the jamming. Special receivers. The basic receiver of the radar system often does not meet with all the requirements of the radar system, nor does it always for the function very well with the uniform of the environment. The special receiver that have been developed that enhance the target deflection unfavorable environment to meet with the requirements of the special transmission scanning method. Radar system moving target indicator system of the non-pulse scanning system requires a special type of the receiver. There are other type of special receivers that a lot of receiver that have been developed and enhance the perception during the unfavorable condition. These receivers will discuss the general term in this section. Moving target indicator system. The moving target indicator system effectively cancels the color of the color of the fixed unwanted echo of the display, but only moving the target signal with the cluster interfere with the radar indicator with the view of the unwanted echo of the interfere with the clearly disturbed display. The desired echo of the cluster is the result of the echo of the land with water, weather, and so forth. The unwanted echo of the shift of the ground color with the echo of the surrounding of the land mass. The G color echo of the irregular triplet with the sheep of the echo of the cloud with the rain with the problem is fine with the start echo of the midst of the cloud to do this in the moving target indicator of the system. The most may be able to distinguish between moving the fixed and moving the targets and the must eliminate only the fixed target that accomplishes with the favor the detection both as opposed comparison. Targeting echo with the station object with the same phase the relation of the one received the period with the neck of the moving object receive the echo signal that have with the differential favor the relationship of one the receiver the period with the neck the principle to allow the moving target indicator system to discriminate between the fixed and moving targets. Signal received from either transmitted pulse with a delay with the period of the time with exactly equal to the pulse repetition time. The delayed signal the big are then combined with the signal with the receiver the next of the transmitted pulse accomplished within the same way with the amplitude with the subject of each other. Others shown figure 230 view A and B with this infinite fixed star with approximately the same amplitude that each of the successive pulse will be eliminated. Moving targeting signals, however, there are also different amplitude with such excessive pulse and therefore do not cancel the resulting signal is then amplified presented on the indicators. Just 1, 2, 3, and 4 cancel signals 2, 1, 3, 2, and 4, 3 fixed target signals delay subtraction circuit receiver PPI the figure 231 with the 30 megahertz signal from the signal mixer applied with the 30 megahertz amplifier. The signal are then amplified limited with the phase detector. They add another 30 megahertz signals obtained with the coherent oscillator mix. They apply with the lock pulse of the coherent oscillator. The coherent oscillator locks the pulse with the originator of the transmitted pulse with the synchronize with the coherent oscillator with the fix of the phase. The relationship with the transmitted fix each of the transmitted pulse 30 megahertz with the Kenshun's wave resonance signal up with the coherent oscillator applied with together the 30 megahertz echo with the signal in the phase detector. Triggered pulse with the modulator with 30 megahertz megahertz law with the coherent oscillator, moving target block diagram. Phase detector produce video signal amplitude. Video signal determine phase difference between the coherent oscillator. The reference for the signal, the intermediate frequency echo, the phase difference for the same between the actual the transmitted pulse with the echo. The resultant video signal may either be positive or negative. The video output of the coherent video that is supplied with a 14 megahertz of the continuous wave carrier oscillator. The 14 megahertz continuous wave carrier frequency, the amplitude modulated phase detect the coherent variety of modulated signal is amplified, applied with the one channel delay. The 14 megahertz for the signal will appear equal to the time between the transmitted pulse. The signal is then applied with the amplified detect with the delay the required with the period between the transmitted pulse. Same the UV the mercury delay line with the fused quartz line delay line with the operates ultrasonically at 14 megahertz. Signal to the other channel with the amplified detect with the no delay and introduce the channel that include the actuating network that introduces the same amount with the actuation of the delay with the line with the delayed video channel with the delay, holding down delay video signal is combined with the opposite polarity with the delayed signal and amplified difference with the if any with the comparison point between the two video signals amplified because of the signal and bipolar that is made unipolar resultant video signal which represent the only moving targets instead of the indicator system for the display. The analysis of the moving target indicator system and the operating with the just described with the shown with the signal with the fixed target with the produced with the phase target with the recurring current video signal the amplitude with polarity fixed target with the have the unchanging phase relation with respect to the transmitted pole with the rest of the one video pulse is combined with the preceding pulse with the opposite polarity with two radio signals cancel but they are not passed on the indicator system. Or signals from the moving target, however, will vary with the phase of the relation with the transmitted with the resulting signal is the best for the receiving period with the produce the signal at a different amplitude with this phase detect for the such signals find the difference of the signal amplitude the provide video signal to the sum of the indicator system display the timing circuit shown figure 231 are used to accurately control transmitter pulse repetition frequency ensure the pulse repetition time with the remain with the concept of the pulse station ensure the core of the pulse arrive at the comparison point to coincide time to achieve the cancellation fixed starts shown Figure 231 with the feedback of the loop achieve the output with the delay channel through the pick off the amplifier with the trigger generator that make everything with the multi-vibrator circular leading edge with the square wave with the produce with the detector carrier wave video channel differentiate with the pick off the amplifier you activate the trigger generator with the getting the multi-vibrator with the trigger generator that send with the amplifier trigger to move with the pulse with the modulator and then call with the radio sent to transmitter. Transmit. The generator gate multivibrator triggered with a negative spike with a differentiated square wave with the stage amplified with 2,000 microseconds. The negative gate with a 14 megahertz with the oscillator opposite is 2400 microseconds with the cut off because of the delay line with 2500 microseconds at 14 megahertz. The oscillator stop with the initial wave with the reach of the end with the delay line. The wave with the train with the detect with the differential term with the gating the multivibrator producing another 2400 microseconds with the wave train with the 100 microseconds with the delay line is necessary to ensure that the mechanical wave of the line have the time the damp out with the next pulse repetition time. In this manner, the pulse repetition time of the radio set with the control of the delay with the mercury with the quartz delay with the line with the because the delay line is commonly the video pulse into the comparison point with the delayed and undelayed video pulse will arrive exactly at the same time. Your logarithmic receiver. The logarithmic receiver is linear logarithmic amplifier commonly called the Lin-log amplifier. Instead of the normal intermediate frequency amplifier, Lin-log amplifier is non-saturating amplifier that does not ordinarily use any special gain control circuits. Output voltage with the Lin-log amplifier of the linear function of the input of the voltage with the low amplitude signal with the logarithmic function with the high amplitude of the signal. In other words, the range linear amplification does not end with the define any saturation point as the case of the normal intermediate frequency amplifiers. Comparison of the representative of the curve of the normal intermediate frequency, the logarithmic amplifier or the Lin-log amplifier called as amplifier shown 232 with the curve is shown with the continued increase of the input of the Lin-log amplifier. It's called the continued increase of the output of the reduced rate with the therefore the large signal does not saturate the Lin-log amplifier rather than merely produce the amplification simultaneously play with a small signal. The small echo signal can often be detected by a logarithmic with the receiver with a normal receiver that will be saturated. Show the output voltage saturation point, the logarithmic intermediate frequency, the normal intermediate frequency input voltage. Typical circuit to obtain with the logarithmic receiver that respond with the shown figure 233. The detectors 2 and 3 are not responsive, not present. The output voltage was not limited by the saturation point. They find with the intermediate frequency of the AJ, the normal intermediate frequency is out with the final state of the logarithmic receiver that is saturated large signal with the increase of the output with the next large stage. The increase of the detector with the detector 2, some of the output with the detector 1, some of the phase of the output even through the final state with the saturated detector 3 cover the output with the continuing the increase after the second stage saturated, the overall gain will become less or less each of the stages saturated because some of the degree of the application is still available. Proper choice of the intermediate frequency stage gain for the saturation points produced at approximately logarithmic response curve. The intermediate frequency in first stage, second stage, final stage intermediate frequency, first detector, second detector, 3 to second sum of detector video. Figure 232, 4 show the response curve of the 3 intermediate frequency stage with the logarithmic amplifier shown in figure 233 with the response of the individual stage produced with the segment overall response curve of the receiver. Show the overall response final stage of the second stage, intermediate and first second stage output voltage monopulse receiver. Most common automatic tracking radar of the monopulse radar is obtained with the three target positions of the coordinate of the range bearing the elevation of the single pulse of the receiver. The non-pulse monopulse radar must have a three separate channel to produce the range of the bearing of the elevation of the information. The block diagram simplified the monopulse receiver figure 235. It's a conventional receiver of each of the channel of the monopulse receiver the return echo of the intermediate frequency of the mixing the return signal with the common local oscillator signal the sum of the amplitude from the return signal of the mix of the local oscillator signal to retrieve the range of the intermediate frequencies and range frequency information from the bearing of the information obtained with the subtracting energy from the horns B and D with the energy from the horns A and C. And mixing the A plus C minus B plus D, mixing the difference with the local oscillator signal, the result of the bearing with the intermediate frequency signal, the elevation information obtained with the same way except for the energy of the horn C and D, the subtraction from the energy from horns A and B, with the A plus B minus C plus D, the target of the elevation belong with the axis consumption will both be zero, therefore neither of the bearing of the no elevation channel will receive the input signal of the bearing with the elevation signal of the often exists input intermediate frequency channel with the produce with the input subsequent converted with the intermediate frequency appropriate channel. The major difference between the monopulse receiver, the conventional receiver, the requirement of the DC air voltage of the output of the bearing and elevation channel for the range the monopulse receiver, the same with the conventional range circuit with the presentation are on the indicator for use of the range tracking circuit. However, since the monopulse radar is the automatic tracking radar of the output of the bearing of the elevation channels must be converted with the DC air signal to the use of the automatic bearing with the elevation tracking. Simply the DC air voltage is applied with the antenna bearing elevation position servo with the servo position antenna will be the arrows are null. The phase detectors common favor the bearing elevation. Intermediate frequency is rated from the intermediate frequency range channel with the comparison produced with the DC arrow pole with the need of the drive of the antenna servo with the signal of both the bearing and elevation channel with the result of the assumption which positive that can be either positive the input favor the negative of 180 degrees the out favor the compare with the reference to intermediate frequency. For example, the output horns with the AC with the small with the output horns B and D are negative 180 degrees is produced with the bearing with A plus D C minus B plus D. If the A plus C with the greater than the output of the B plus D with the power of the input phase and the input phase with the signal produced with the bearing channel, the phase out of the bearing elevation output signal to determine the direction with the antenna move with the magnitude of the signal to determine the amount of the movement. The two signals must present at the phase of the detector with the produce the output of the air of the curve with the only return echoes not in the antenna of the beam axis. The technique produced the air with signal with the target move with the radiated with the beam axis with either bearing elevation air signals the antenna to move in the proper direction for the proper duration. The camp of the air signal the method of the automatic tracking is commonly used with the weapons control tracking radar system. Alright, chapter 2 summary.